So next up for this second lesson here, we're going to look at roots. So looking at these roots, how many unique x-intercepts does the graph have? So I'm going to do some sketches here of some different types of graphs, some linear, quadratic, cubic, and quartic, okay? And then we're going to look at kind of the unique x-intercepts, okay? And then we'll kind of connect it all together and see what this means. So when looking at a linear function, here's the deal. You can have pretty much 0 or 1 x-intercept. Now, the 0 is going to give you a horizontal line. That gets a little weird because then you're not really kind of looking at a polynomial, okay? So I'll be honest, we're not really going to do too much there. Instead, most of our linear functions, they're not a horizontal line like that, okay? You know, they're going to look something like this. Here's one with a negative slope, okay? Either way, look, it has one kind of unique x-intercept right there. It's going to hit your x-axis once, regardless of positive or negative slope. You have your one x-intercept, one solution, 1, 0, 1 root. Okay. Now, quadratic, you have a couple different options. So, looking at quadratics here, all right, our first one we're going to look at is you can draw a quadratic that has 0 x-intercepts. So, now I could open this up, kind of, you leave it open or kind of closed, flip it down. All right, so let's flip one down. If I do this, like, look, this does not hit the x-axis at all. So you can have a quadratic that does not have any x-intercepts, so 0. You can have a quadratic that hits once. So let's open this one back up. Let's go, I don't know, let's go over here. This is going to come down and like hit your x-axis once at the vertex, okay? Not a great U-shape, sorry about that. But our last type here is the majority of quadratics are probably going to be mostly like this, where you're going to come down and hit your x-intercepts twice. Okay, or hit your x-axis twice, excuse me. 2 x-intercepts, there we go. Same thing, not the best to use, sorry about that, I need to clean that up. So you kind of have some options with quadratics, but those are kind of at most, oh, didn't do that circle, at most what you're going to have. So jumping down here to cubic. Okay, so cubic is going to be a little interesting. So if you think about end behavior that was kind of in the last page, all right, those end behavior notes. Okay, guys, a cubic function, you're going to have one arrow going up, one arrow going down. Now, depending on the positive, negative trend, depending on where the arrow is, okay? But if you have one arrow going up, one arrow going down forever, like you have to hit the x-intercept once. Okay, so one example of this would be like, let's do a positive trend. If I go up, hit the x-axis once, maybe curve back down and then jump back up, boom. There's my one x-intercept, okay? So think about how I could maybe slightly modify that one I just drew so that it hits twice. Well, take a look. Let's kind of use the same idea. Hits once, come back down, and maybe it just touches that x-axis right there. Okay, and then last time 3, same thing. I could modify this one slightly so that it hits 3 times. So let's go shoot through this. Let's shoot through the x-axis again, and then shoot it back up. And there, look, 1, 2, 3. Okay, so at most you can have is 3 x-intercepts here. But you can also draw graphs that just hit the x-axis twice, hit the x-axis once. So the last one, quartic. So going back to kind of an even function, since your arrows go in the same direction, thinking about end behavior, all right, it is possible that you have a quartic function that never hits the x-axis. So maybe something like this. Look, doesn't hit the x-axis. So 0. Same deal as kind of I did with cubic. I can kind of slightly modify this. So look, you could hit the x-axis once, go down here, and then everything else stays kind of north of that x-axis. Okay, 2, maybe let's flip this over, okay? So I can keep going, but let's flip it over. Let's go, okay, it goes up, hits your x-axis, comes back down, goes back up, hits the x-axis again, and then shoots back down. So 2 is possible. Okay, 3. 3 is a little bit different. So maybe let's shoot back up. Okay, so let's go back down here. So let's go up, I can go up back through, and then look, if I come back down and graze this last one, then look, I just made 1, 2, 3 x-intercepts. Okay, and then the last one I can make here is 4. This is one that's going to kind of bounce back and forth above and below the x-axis. So like, look, 1, 2, 3, 4. That would work. All right, 1, 2, 3, 4. Now, obviously, I shot a lot of these up. Once again, it could shoot down like I did for this one. I really could do that for any of them, depending on your end behavior and your leading coefficient, okay? So as I kind of look at this page, here's what I want you guys to notice is, take a look. The highest number of x-intercepts that I can have is equal to your degree. Like, it's not possible for me to draw 5 x-intercepts and it'd be a quartic. And same thing for cubic. Cubic can't have 4, quadratic can't have 3, linear can't have 2. Okay, it's not possible. So look, the maximum, and this will be important, I'll talk about this to finish up this page. All right, the maximum number of unique turning points is going to be equal to the degree, not turning points, sorry, excuse me. Roots is going to be equal to its degree. Okay, so that word maximum is important because if you take a look, all right, obviously that's where the x-axis, okay, can hit 4 times. It's a degree of 4. But then I just showed you there's other graphs where it can only hit 3, 2, 1, 0. So the bottom part here is, that's the number of unique roots, okay? You can have double roots. You can have imaginary roots, okay? So you will always have the number of roots equal to the degree, okay? But the number of unique and different roots could be a little bit different, okay? So, like I said, you might have double roots, you might have imaginary roots, but altogether, the number of roots should equal the degree. That's the main idea that we're looking at here. You won't always see it on a graph because it won't always be the x-intercepts, especially if they're imaginary. You won't see it as an x-intercept, and if it's a double root, you'll see different things happening that we'll talk about later. But the max number of, or the number of roots is going to be equal to your degree.